In this video, we're going to focus on dividing polynomials using synthetic division. In addition, we're going to talk about how to factor polynomials and find the zeros or the roots using synthetic division, and also how to evaluate functions using the remainder theorem. So let's begin. Let's say if we have the polynomial 2x cubed plus 5x squared minus 6x plus 9. And let's say that we want to divide it by x minus 3 using synthetic division. How can we do so? If you set the factor x minus 3 equal to 0, x is equal to 3. So what we're going to do is we're going to divide the polynomial by this number 3. Now to use synthetic division, what you want to do at this point, write the coefficients 2, 5, negative 6, and 9, and you want to place them here. And then bring down the 2. 3 times 2 is equal to 6. And then add 5 and 6. So 5 plus 6 is 11, and then multiply 3 and 11. 3 times 11 is 33. Negative 6 plus 33 is 27. And 3 times 27, well, that's 81. 81 plus 9 is 90. So that's how you can divide using synthetic division. Now, we're not done yet. There's a few more things that we need to do. Now, we need to write these numbers in terms of a polynomial. If you divide x cubed by x, you're going to get x squared. So this is going to be 2x squared plus 11x plus 27. And the last number is the remainder. It's going to be a remainder of 90 divided by what you tried to divide it by, which is x minus 3. So this is the answer. This portion here is the quotient, and this portion is the remainder. Now let's confirm our answer using long division. Now we're going to write it this way. We're going to put the x minus 3 on the outside, and on the inside we're going to put the polynomial function 2x cubed plus 5x squared minus 6x plus 9. So now what is 2x cubed divided by x? 2x cubed divided by x is 2x squared. So we're going to divide, and now we're going to multiply. 2x squared times x is 2x cubed. 2x squared times negative 3 is negative 6x squared. So now let's subtract. So 2x cubed minus 2x cubed is 0. 5x squared minus negative 6x squared is the same as 5x squared plus 6, because these two negative signs will turn into a positive sign. So this is going to be positive 11x squared. Negative 6x minus nothing, or 0, is simply negative 6x. So these two terms, we can just bring them down. And now let's repeat the process. We're going to divide, multiply, and then subtract. So let's divide first. 11x squared divided by x is 11x. And now let's multiply. 11x times x is 11x squared. 11x times negative 3 is negative 33x. And now subtract. 11 minus 11 is 0. Negative 6 minus negative 33, and that's the same as negative 6 plus 33, which is positive 27x. And now let's divide again. 27x divided by x is 27. And so now let's multiply. 27 times x is 27x. 27 times negative 3 is negative 81. So if we subtract 27x minus 27x is 0. 9 minus negative 81 That's 9 plus 81, so that's 90. So as you can see, we have the quotient on top and a remainder of 90 on the bottom. So to write that as an answer, it's 2x squared plus 11x plus 27 plus the remainder 90 divided by what you tried to divide it by, which is x minus 3. So this is the solution. Let's try another example. Divide the polynomial 3x to the fourth minus 5x cubed plus 6x squared minus 7x plus 9. Go ahead and divide it by x plus 4 using synthetic division. Let's set x plus 4 equal to 0. So x is negative 4. And let's write the coefficients on the board. So it's going to be 3, negative 5, 6, negative 7, and 9. So let's bring down the 3. That is a terrible arrow. Negative 4 times 3 is negative 12. Negative 5 plus negative 12, that's negative 17. And negative 4 times negative 17, that's positive 68. 68 plus 6 is 74. And at this point, I think I'm going to use a calculator. So negative 4 times 74 is negative 296. And if we add negative 7 to that, it should be negative 303. And negative 4 times negative 303, that's 1219. And if we add 9 to that, it's 1221. X to the fourth divided by x is x cubed. So the final answer should be 3x cubed minus 17x squared plus 74x minus 303, and then plus the remainder, which is 1221, divided by x plus 4. So that is the solution to the problem. So now you know how to divide polynomials using synthetic division. But now let's talk about some other applications of synthetic division. And one typical use of it is evaluating functions. So let's say if you have the function f of x is equal to 2x cubed plus 5x minus 9. And let's say if you want to evaluate or find the y value when x is 2. Now 2 is a small number, so we could just plug it in. So this is going to be 2 times 2 raised to the third power plus 5 times 2 minus 9. 2 to the third power, that's 2 times 2 times 2, 3 times, that's 8. 5 times 2 is 10, and 2 times 8 is 16. 10 minus 9 is 1. 16 plus 1 is 17. So therefore, f of 2 is 17. When x is 2, y is 17. Now sometimes, this might be a very long polynomial. And is there an easier way to get that answer? This method may be easy, it may be longer, it depends on how long the polynomial is, but you can use synthetic division. So let's put a 2. Now it's important to understand that this expression is equivalent to 2x cubed plus 0x squared plus 5x minus 9. So you need to write the 0 for this to work, even if the x squared is not present. So let's put the numbers 2, 0, 5, and negative 9. So let's bring down the 2 first. 2 times 2 is 4. 0 plus 4 is 4. And then 2 times 4, that's equal to 8. 5 plus 8 is 13. 2 times 13 is 26. Negative 9 plus 26, or 26 minus 9, that's equal to 17. So notice that the remainder is equal to the solution. So that's another way in which you can evaluate a function using the remainder theorem. Let's try another example. Let's say that f of x is equal to x cubed minus 5x squared plus 2x minus 3. Go ahead and evaluate f of 3 using conventional methods and synthetic division. So let's begin by plugging in 3 into the equation, or into the function. So what is 3 to the third power? 3 times 3 is 9, and 9 times 3 is 27. 3 squared, that's 3 times 3, that's 9, and 2 times 3 is 6. 5 times 9 is 45, and 6 minus 3 is 3. Now, if we add 27 plus 3, that's equal to 30. And 30 minus 45 is equal to negative 15. So this is the final answer. Now, let's use synthetic division to confirm that f of 3 is indeed equal to negative 15. So we're going to put a 3 on the outside, and then the coefficients 1, negative 5, 2, and negative 3 on the inside. So let's bring down the 1. 3 times 1 is 3. Negative 5 plus 3 is negative 2. 3 times negative 2 is negative 6. And 2 plus negative 6 is negative 4. 3 times negative 4 is negative 12. And negative 3 minus 12 is negative 15. So as you can see, we get the same answer. Now let's talk about how to factor polynomials using synthetic division. And at the same time, we're also going to talk about how to use that information to find the zeros or the roots of a polynomial. So let's say if x cubed minus 7x plus 6 is equal to 0. How can we factor this expression in order to solve for the value of x? To find the possible factors, take a look at the constant term. Factors of 6 are 1, 2, 3, and 6. So these are possible solutions. Factors of the leading coefficient 1 is simply just 1. So potential solutions are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now, before we can use synthetic division, we need to find one answer that works. So it's best to start with positive 1 or negative 1. Let's start with positive 1. 1 to the third minus 7 times 1 plus 6. We need to see which possible 0 will give us a value of 0. 1 to the third is 1. 7 times 1 is 7. 1 minus 7 is negative 6. Negative 6 plus 6 is 0. So a next value of 1 is one of the zeros. It's one of the solutions we're looking for. So we can write x is equal to 1. Now let's use synthetic division to find the other solutions, or the other zeros. Now let's not forget that there is an x squared that's missing. So if it's not there, use a 0. The coefficient in front of it is 0. So we're going to put 1, 0 for 0x squared, negative 7, and 6. Let's bring down the 1. So 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 7 plus 1 is negative 6. 1 times negative 6 is negative 6. And these two add to 0. So if you get a remainder of 0, that means that x equals 1 is the solution to the equation. Now, if x is 1, the factor is x minus 1, because if you set x minus 1 equal to 0, x is 1. If you divide x cubed by x, the first term is going to be x squared. So this is 1x squared plus 1x minus 6. So therefore, to factor the expression x cubed minus 7x plus 6, it's going to be x minus 1, which we got from this solution, times x squared plus x minus 6. If you were to FOIL these two expressions, you would get x cubed minus 7x plus 6. So that's how you can factor it using synthetic division. But now we have a trinomial, and let's see if we can factor it. What two numbers multiply to negative 6 but add to the middle term 1? Negative 6 is 3 times negative 2, and 3 plus negative 2 adds up to 1. So to factor x squared plus x minus 6, it's going to be x plus 3 times x minus 2. So that's how you can completely factor a polynomial using synthetic division. To find the zeros, it's simply going to be x equals 1, x equals negative 3, and x equals 2. So these are the zeros of the polynomial function. Let's try another example. Go ahead and factor the expression x cubed plus 4x squared plus x minus 6. So feel free to pause the video. Go ahead and work on this example. Let's find the possible factors of 6. Possible factors of 6 are 1, 2, 3, and 6. So let's start with 1. Let's see if we plug in 1 if that's going to give us 0. So we have 1 to the third plus 4 times 1 squared plus 1 minus 6. 1 cubed is 1. 1 squared is 1 times 4. And 1 plus 4 plus 1 is 6. 6 minus 6 is 0. So 1 is once again a solution. So as a factor, it's going to be x minus 1. So now let's use synthetic division. So we're going to have the coefficients 1, 4, 1, and negative 6. 1 times 1 is 1, 4 plus 1 is 5, 1 times 5 is 5, and 1 plus 5 is 6, 1 times 6 is 6, and if you add those two you get 0. So we're left with the polynomial 1x squared plus 5x plus 6. So therefore, to factor this expression, it's going to be this, x squared plus 5x plus 6 times x minus 1, the other factor. And we can factor this particular trinomial. What two numbers multiply to 6 but add to positive 5? 3 times 2 is 6, but 3 plus 2 is 5. So this is going to be x plus 3 times x plus 2 times x minus 1. And all of this is equal to 0. So therefore, x is equal to negative 3, negative 2, and positive 1. So these are the zeros of the function. Try this one. 2x cubed minus 3x squared minus 2x plus 3. So factors of 3 are plus and minus 1 and plus and minus 3. Factors of the leading coefficient 2 are plus and minus 1 and plus and minus 2. So 1 divided by 1 is 1, So we have possible factors of 1. 3 divided by 1 is 3. So 3 could be a factor. And 1 divided by 2 is a half. So 1/2 is a potential factor, or 3/2 is another potential factor. So let's start with 1. So if we plug in 1, will it equal 0? This is 2 minus 3 minus 2 plus 3. 2 and negative 2 will cancel, they add to 0. Negative 3 plus 3 is 0 as well. So 1 works. So if x is equal to 1, we have the factor x minus 1. So now let's use synthetic division. Let's put the coefficients 2, negative 3, negative 2, and 3 on board. 1 times 2 is 2, negative 3 plus 2 is negative 1. 1 times negative 1 is negative 1. If we add negative 2 to that, that's going to be negative 3. And 1 times negative 3 is negative 3. And 3 and negative 3 adds to 0. So we're left with 2x squared minus 1x minus 3. So now how can we factor this particular trinomial where the leading coefficient is not 1? What would you do? Right now, our factored expression is 2x squared minus x minus 3 times x minus 1. To factor this particular expression, multiply the constant term by the leading coefficient. 2 times negative 3 is equal to negative 6. And you want to find two numbers that multiply to negative 6 but add to the middle coefficient, negative 1. So this is going to be negative 3 and 2. Negative 3 plus 2 adds up to negative 1. So let's replace negative 1x with negative 3x and 2x. And then we can factor by grouping. So in the first two terms, take out the GCF, which is x. 2x squared divided by x is 2x. Negative 3x divided by x is negative 3. For the last two terms, there is no GCF, so let's take out a 1. And we're just going to have 2x minus 3 on the inside. So now, let's factor out 2x minus 3. Now what's going to go inside the next parentheses? It's what's on the outside, x plus 1. So therefore, we can replace 2x squared minus x minus 3 with 2x minus 3 times x plus 1. And we have an x minus 1 next to it. Now let's set the function equal to 0. And let's solve for x. Let's find the zeros of the function. So let's set each of the three factors equal to 0 separately. So 2x minus 3, x plus 1, and x minus 1. If x minus 1 is equal to 0, we need to add 1 to both sides. Therefore, x is equal to positive 1. So that's the first 0. If x plus 1 is equal to 0, we need to subtract 1 from both sides. So x is equal to negative 1. That's the second 0. And for the last one, let's add 3 to both sides. So 2x is equal to 3. And then let's divide both sides by 2. So x is equal to 3/2. Now remember the possible factors that we had in the beginning. Actually, let me keep the first part. Possible factors of 3 were 1 and 3, and possible factors of 2 were 1 and 2. Notice that we do have 3/2 as an answer. So this technique tells you the possible factors. So the answers that you see here are included in the list of possible zeros. Now let's go back to the original expression, 2x cubed minus 3x squared minus 2x plus 3. Notice that the first two terms have the same ratio as the last two terms. Negative 3 divided by 2 is the same as 3 divided by negative 2. Whenever you see that, you can factor by grouping at the very start. So let's do it that way. In the first two terms, let's take out the GCF, which is x squared. So 2x cubed divided by x squared is 2x. Negative 3x squared divided by x squared is negative 3. In the last two terms, all we could do is take out a negative 1, and we'll be left with 2x minus 3. So if you see this common factor, you know you're on the right track. So this is going to be 2x minus 3 times what we see on the outside, x squared minus 1. Now, x squared minus 1 is in the form of a difference of perfect squares, so we can factor it by taking the square root of x squared, which is x. The square root of 1 is 1, and one of them is going to be positive, the other will be negative. So as you can see, we have the same answer. X is equal to 3 over 2, negative 1, and 1, if this whole thing is equal to 0. Try this one. X cubed minus 2x squared plus 4x minus 8. So for this example, do we have to use synthetic division to factor it and to find the zeros, or can we factor by grouping? So notice that the first two terms have the same ratio as the last two terms. Negative 2 divided by 1 is negative 2, and negative 8 divided by 4 is negative 2. So we could factor by grouping. But for the sake of practice, factor using synthetic division and then confirm that answer by factoring by grouping. So let's find the possible zeros. So possible factors of 8 are 1, 2, 4, and 8, divided by the possible factors of 1. So that's not going to change anything. So let's start with 1. Let's see if positive 1 is a factor. One cubed is 1. 1 squared times 2 is 2. This is 4, and then minus 8. 1 minus 2 is negative 1. 4 minus 8 is negative 4. These two do not add to 0. So 1 is not a factor. Let's try 2. So 2 to the third power minus 2 times 2 squared plus 4 times 2 minus 8. 2 to the third power, that's 2 times 2 times 2, that's 8. 2 squared is 4. 4 times 2 is 8. 2 times 4 is 8. So we have a lot of 8s. 8 minus 8 is 0, so the whole thing is 0. So 2 is a factor. So now let's use synthetic division. So it's going to be 1, negative 2, 4, and negative 8. So let's bring down to 1. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. 4 plus 0 is 4. 2 times 4 is 8. Negative 8 plus 8 is 0. So we're dividing x cubed by x minus 2. X cubed divided by x is x squared, so this is going to be 1x squared plus 0x plus 4, which is the same as x squared plus 4. So therefore, if we factor it, it's going to be x squared plus 4 times x minus 2. Now let's factor by grouping to confirm that answer. So let's take out the GCF in the first two terms and in the last two terms. So the greatest common factor in the first two terms is x squared. X cubed divided by x squared is x. Negative 2x squared divided by x squared is negative 2. Now for the last two terms, the greatest common factor is 4. 4x divided by 4 is x. Negative 8 divided by 4 is negative 2. So now let's factor the common term, which is x minus 2. What we have on the outside, as you can see, x squared plus 4. So we get the same answer. So now that we have these factors, let's solve for x. So we have x squared plus 4 is equal to 0, and x minus 2 is equal to 0. So we know that one of the solutions is x is equal to 2. That's 1, 0, or 1 root. Now for the other one, let's move the 4 to the other side. And let's take the square root of both sides. So x is equal to plus or minus the square root of negative 4. Now this is the same as the square root of 4 times the square root of negative 1, since 4 times negative 1 is negative 4. You need to know that the imaginary number I is equal to the square root of negative 1. So therefore, this is going to be plus or minus the square root of 4 is equal to 2, and the square root of negative 1 is I. So it's plus or minus 2i. So therefore, the solution to this equation is this. We have one real 0, or one real solution, which is 2, and we have two imaginary solutions, 2i and negative 2i. So there's a total of 3 solutions. Now what if you have a problem that looks like this? 3x cubed minus x squared plus 7x plus 6. So go ahead and solve for x. Find the zeros of this particular function. Now, can we factor by grouping? Negative 1 divided by 3 is not the same as 6 divided by 7. So the first two terms and the last two terms do not have the same ratio. So we cannot factor by grouping. So we have to use synthetic division. So let's find the possible factors of 6. Possible factors of 6 are 1, 2, 3, and 6. Possible factors of 3 are just 1 and 3. So the zeros could be the numbers on top, 1, 2, 3, and 6, or it can be 1 over 3. It can also be plus or minus 2 over 3. And it's not going to be 3 over 3 because that's the same as 1 over 1. And 6 over 3 is 2, so those are the possible zeros. 1, 2, 3, 6, 1/3, and 2/3, plus or minus for all of them. So let's start with 1. Let's see if that's going to be a possible factor. So 3 times 1 cubed minus 1 squared plus 7 times 1 plus 6. This is 3 minus 1 plus 7 plus 6. That's 2 plus 7 plus 6, which is 9 plus 6, and 15. So that's not 0. So 1 is not a factor. Let's try negative 1. Negative 1 to the third power is negative 1 times 3. That's negative 3. Negative 1 squared is positive 1, and 7 times negative 1 is negative 7. Negative 3 minus 1 is negative 4. Negative 7 plus 6 is negative 1. And negative 5 does not equal 0. So negative 1 is not a solution. Let's try 2. So 3 times 2 to the third minus 2 squared plus 7 times 2 plus 6. 2 to the third is 8. 2 squared is 4. 7 times 2 is 14. 3 times 8 is 24. 16 plus 4 is 20. 24 minus 4 is 20. And this does not equal 0. So let's try negative 2. Negative 2 raised to the third power is negative 8. Negative 2 squared is positive 4. 7 times negative 2 is negative 14. 3 times negative 8 is negative 24. Negative 14 plus 6 is negative 8. Negative 24 minus 4 is negative 28. So this is not going to work. This is negative 36. Now this can be a long process. And sometimes it might be useful to graph the function and find out where it touches the x-axis, because that can give you the first zero, and then once you have that, you can use synthetic division to find the rest. So if you're ever having a difficult time finding the zeros, if you're allowed to use a graphing calculator, use it. Find out where it touches the x-axis, and then plug that in to see if that is indeed a zero, which it should be. Now let's try 3. If you don't have access to a graphing calculator, this is what you're going to have to do. Now what's 3 to the third power? 3 times 3 times 3 is 27. 3 squared is 9. And 7 times 3 is 21. Now 3 times 27 is 81. So at this point, you can see that 81 is a very large positive number, and there's no way this is going to equal 0. So 3 is not going to work. Let's try negative 3. Negative 3 to the third power is negative 27. And negative 3 squared is 9. 7 times negative 3 is negative 21. This is negative 81 minus 9 minus 21 plus 6, which is clearly not going to be 0. Now we can try 6. But I doubt it's going to be 6, because 6 to the third power is 216 times 3. There's nothing that's going to bring that to 0. So we're probably going to have to try a fraction. Keep in mind, the factors were 1, 2, 3, and 6 divided by 3 and 1. So it could be 1/3 or 2/3. Let's try 2/3 to begin with. And then if that doesn't work, we'll try negative 2/3. So 2 to the third power is 8. 3 to the third power is 27. 2 squared is 4. 3 squared is 9. 7 times 2 is 14. And this is what we have so far. Now what's 3 times 8 over 27? What you could do is divide it backwards. 27 divided by 3 is 9. So this is going to be 8 over 9. Now 6, I'm going to multiply the top and bottom by 3 and turn that into 18 over 3. Eight over 9 minus 4 over 9 is 4 over 9. 8 minus 4 is 4. 14 plus 18 is 32. So now, let's multiply. Well, we can clearly see that this is not going to add to 0. So we can stop here. 4 over 9 plus 32 over 3 is a positive number, so we can leave it. Let's try negative 2 over 3. Negative 2 to the third power is negative 8. 3 to the third power is 27. Negative 2 squared is 4. 3 squared is 9. And then this is going to be negative 14 over 3 plus 6 over 1, which is really 18 over 3. So 27 divided by 3 is 9 again. So this is going to be negative 8 over 9 minus 4 over 9. And negative 14 plus 18 is positive 4, or 4 over 3. Negative 8 over 9 minus 4 over 9. Negative 8 minus 4 is negative 12, which this is looking good because we can reduce negative 12 over 9 to negative 4 over 3. Let's divide both numbers by 3. Negative 12 divided by 3 is negative 4. 9 divided by 3 is 3. So patience is well rewarded. Negative 4/3 plus 4/3 is 0. So we found our first 0. So x is equal to negative 2 over 3. So now let's use synthetic division. So the coefficients are 3, -1, 7, and 6. Now let's bring down the 3. So what is -2/3 times 3? The 3's will cancel. 3 divided by 3 is 1. So this is simply -2. Now let's add -1 plus -2. That's -3. -2/3 times -3 is equal to, the 3's will cancel again. -2 times -1 is simply 2. So it's going to be +2 this time. And 7 plus 2 adds up to 9. So now let's multiply -2/3 times 9. So -2/3 times 9. Let's divide first. 9 divided by 3 is 3, times -2 is -6. Or you could do -2 times 9 is -18 divided by 3, and you'll still get the same answer, -6. 6 plus -6 adds to 0, which tells us that -2/3 is indeed a solution to the equation. So this is going to be 3x squared minus 3x plus 9. Now, how can we convert this solution into a factor? How can we do that? So we need to adjust this equation, so to speak. And to do that, let's multiply both sides by 3. So 3x is equal to, the 3's will cancel, so 3x is equal to -2. And now what we're going to do is add 2 to both sides. So 3x plus 2 is equal to 0. That's how you can turn a solution into a factor. You need to get a 0 on one side. So therefore, to factor the polynomial, the original polynomial, this function, it's going to be 3x plus 2 times 3x squared minus 3x plus 9. So let's see if we could factor this particular trinomial. We see that it has a GCF of 3, so let's take that out. And then on the inside, we need to be careful with something, because I multiplied this by 3. Let's change it. We have to be careful with this question. Instead of multiplying by 3, let's add 2/3 to both sides. So we have this, x plus 2/3 is equal to 0. I'm going to use this as a factor. The reason being is 3x times 3x squared is 9x cubed, which is not 3x cubed. So we need to take that into account. So let's get rid of this particular factor, and let's use x plus 2/3. Because x times 3x squared is 3x cubed. And when we use -2/3 as a solution, this is what we received. But notice what's about to happen. Notice that we can take out a 3 from this expression. So it's going to be 3 times 3x squared divided by 3 is x squared. -3x divided by 3 is -x. 9 divided by 3 is +3. And notice that we can take this 3 and distribute it to x plus 2/3. So we can get rid of this fraction. So 3 times x is 3x, and 3 times 2/3 is 2. So we have the expression 3x plus 2 times x squared minus x plus 3. So this is the most reduced factored form, or the appropriate factored form for this expression. And just to make sure our answer is indeed correct, let's FOIL these two terms to prove that it's equal to the expression above. 3x times x squared is equal to 3x cubed. 3x times negative x is negative 3x squared. And 3x times 3 is 9x. 2 times x squared is 2x squared. 2 times negative x is negative 2x. And 2 times 3 is 6. Now let's combine like terms. So we can combine negative 3x squared and 2x squared. That's going to be negative x squared. And then 9 minus 2 is 7. So notice that we get the original polynomial. Which means that this is the correct answer in factored form. So now let's see if we can factor the trinomial x squared minus x plus 3. So what two numbers multiply to 3 but add to negative 1, the middle term? The only two numbers that multiply to 3 are 1 and 3, or negative 1 and negative 3. 1 plus 3 is 4, negative 1 plus negative 3 is negative 4. They do not add to negative 1. So if you get a trinomial where you cannot factor it, you need to use the quadratic equation. So whenever you have a trinomial in standard form, ax squared plus bx plus c, so we can see that a is equal to 1, b is negative 1, c is 3. Whenever you have a trinomial in that form, you can use the quadratic equation. So x is equal to, here's the formula, negative b plus or minus square root b squared minus 4ac divided by 2a. And we said that a is the number in front of x squared, which is a 1. B is the number in front of x, which is negative 1. And c is the constant term 3. So it's going to be negative 1 plus or minus square root negative 1 squared minus 4 times a, which is 1, times c, which is 3, divided by 2a, or 2 times 1. So this is going to be equal to negative times negative 1 is 1. 1 squared is 1. Negative 4 times 1 times 3 is negative 12 divided by 2. So this is 1 plus or minus square root negative 11 divided by 2. Whenever you have a negative number inside a square root, you have an imaginary number. So this is a complex imaginary root. So it's 1 plus or minus square root 11i times, or divided by 2. So x is equal to, there's three answers. The first answer, which comes from this factor, is negative 2 divided by 3. That's a real solution. The second answer is 1 over 2 plus radical 11 times I. That's an imaginary answer. And the other one is 1 over 2 minus radical 11 over 2 times I. We need to divide both the 1 and the square root 11 by 2. So these are the solutions. Now what if you have a problem where you're given a polynomial to the 4th degree? Go ahead and try this one. So possible factors of 8 are 1, 2, 4, and 8. Let's start with 1. Let's see if 1 is a potential solution. So this is 1 minus 1 plus 2 minus 4 minus 8. 1 minus 1 is 0. Negative 4 minus 8 is negative 12. 2 minus 12 is negative 10. So that does not work. Let's try negative 1. Negative 1 to the fourth is 1. Negative 1 to the third is negative 1. Negative 1 squared is 1. Negative 4 times negative 1 is plus 4. 1 minus negative 1 is the same as 1 plus 1, which is 2. 2 plus 2 is 4. 4 plus 4 is 8. 8 minus 8 is 0. So negative 1 is a factor. So let's use synthetic division. So the coefficients are 1, negative 1, 2, negative 4, and negative 8. So negative 1 times 1 is negative 1. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 2 is 2. 2 plus 2 is 4. Negative 1 times 4 is negative 4. If you add those two, you get negative 8. Negative 1 times negative 8 is positive 8, which adds to 0. So what we have left over is x cubed minus 2x squared plus 4x minus 8. Now, since we use negative 1, that means x plus 1 is a factor. So to factor the polynomial to the fourth degree, the one that we have on the board, it's going to be x plus 1 times x cubed minus 2x squared plus 4x minus 8. So let's focus on factoring this expression. Notice that the first two terms have the same ratio as the last two terms. Negative 2 divided by 1 is the same as negative 8 divided by 4. They're both equal to negative 2. So let's take out the GCF. So let's factor out an x squared. This is going to be x minus 2. And from the last two terms, let's take out a 4. And that's going to be x minus 2 again. So this is going to be x minus 2 times x squared plus 4. So now we could find the zeros of the polynomial. So we know it's going to be negative 1, positive 2, and for x squared plus 4, we solved that earlier in this video. It's going to be plus or minus 2i. If you set x squared plus 4 equal to 0, move the 4 to the other side, then take the square root of both sides. The square root of 4 is 2, and the square root of negative 1 is I, so you get plus or minus 2i. So there's 4 solutions, 2 of which are imaginary, and the other 2 are real solutions. So this is going to be the last example for this video. Go ahead and factor this polynomial of fourth degree. So the constant term is 30. Factors of 30 are 1, 2, 3, 5, 6, and 10, and 15, and 30. So let's start with 1. So this is going to be 1 minus 1 minus 11 plus 5 plus 30. Just by looking at this, you can see that this is not going to work. If we chose negative 1, this is going to be 1 plus 1 minus 11 minus 5 plus 30. There's no way that's going to add up to 0. So let's move on to 2. Two to the fourth is 16. 2 to the third is 8. 2 squared is 4. 5 times 2 is 10. And 16 minus 8 is 8. 11 times 4 is 44. 10 plus 30 is 40. Negative 44 plus 40 is negative 4. So this is close. It's not too far away from 0, so we're on the right track. Let's try negative 2. Negative 2 to the 4th is 16. Negative 2 to the 3rd is negative 8. And negative 2 squared is 4. 5 times negative 2 is negative 10 plus 30. So this is 16 plus 8 minus 44. Negative 10 plus 30 is 20. 16 plus 8 is 24. And negative 44 plus 20 is negative 24, which adds to 0. So negative 2 is a factor. So x is equal to negative 2. Now let's use synthetic division. So the coefficients are 1, negative 1, negative 11, 5, and 30. So let's bring down 1. Negative 2 times 1 is negative 2. Negative 1 plus negative 2 is negative 3. And then negative 2 times negative 3 is 6. Negative 11 plus 6 is negative 5. Negative 2 times 5, or negative 2 times negative 5, that's 10. And if we add these two, we get 15. Times negative 2 is negative 30. And this adds to 0. So this is x cubed minus 3x squared minus 5x plus 15. Now notice that we can factor by grouping. But right now, the answer so far that we have in factored form is x plus 2 times x cubed minus 3x squared minus 5x plus 15. Now notice that the first two terms have the same ratio as the last two. Negative 3 divided by 1 is the same as 15 divided by negative 5. Both of these numbers is equal to negative 3, which means we could factor by grouping. So in the first two terms, let's take out an x squared. And then we'll be left with x minus 3. And if we take out negative 5, negative 5x divided by negative 5 is x. 15 divided by negative 5 is negative 3. So now we can take out the common term, x minus 3. So it's x minus 3 times x squared minus 5. And then multiplied by x plus 2. Now we could factor x squared minus 5. So our final answer is x plus 2 times x minus 3. And using the difference of squares technique, it's x plus radical 5 times x minus radical 5. So therefore, there's 4 real answers. Negative 2 plus 3, negative square root 5, and positive square root 5. So that is it for this video. Thanks for watching, and have a great day.